Hello everybody, welcome to what is probably the first video for Math 9A. Let me just welcome you to the course if this is your first video watching. This is the introductory video to the rational number unit. So before we get into the unit, we should really understand what a rational number is. If we think about numbers, we can kind of break them up into different categories, right? Like if you think about when numbers were first created, what use would they have had for those? Well, they would have looked at things in the real world and said, oh, I have 5 apples, or I have 2 horses, right? So we call those the natural numbers, or in other words, the counting numbers, right? So numbers like 1, 2, 3, 4, 5, 6, 7. But then what happened is as our need for numbers grew and grew, our understanding of numbers had to grow with it. And with that, we developed new groups of numbers other than the natural numbers. So we have numbers like what we call the whole numbers. And what that does is it simply just adds a 0 to the natural numbers. And then we get into what is called the integers. And what is an integer? Well, an integer is just like the natural numbers. It is countable numbers. So numbers like 0 and 1, 2, 3, 4, 5. But it's also the negative numbers as well. Okay, so really the only difference between a positive number and a negative number is simply just direction, right? If I think about negatives as I am losing something and positives as I am gaining something, or negatives as going to the left and positives as going to the right, really there is no difference between a positive and a negative number other than just the direction that things are moving. So what is a rational number? Well, a rational number is any number that can be thought of or written as a number in a fraction, or in other words, a number written as some integer m over some integer n. And I know what you're thinking, letters in math, not okay with that, but all this m and n they're just holding the place of a number. So m could be 1 and n could be 2, or m could be -5 and n could be 7, right? They're just standing in the place of 2 numbers. The only restriction here is that n is not allowed to be 0. And the reason n is not allowed to be 0 is relatively straightforward. Because these rational numbers are considered fractions, and fractions are simply just another way of considering division, what happens when I try to divide by 0? So if I took my calculator and I typed in 5 divided by 0, or as a fraction 5 over 0, what happens is my calculator gives me an error. It doesn't like that. It says, whoa, 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 we can't do that. And that kind of makes sense if we think about it in a context, right? So if I were to take 10 friends and I wanted to split them up into 2 equal teams, that is 10 divided by 2, and we get 5 people per team. But if I had 10 friends and I wanted to split them up into 0 teams, well, how many people go into each team? Well, the problem is there isn't even a team for people to go into, right? So that is the issue when we start trying to divide by 0, is we kind of lose this contextual understanding of what a division is, and it kind of breaks up, it falls apart, right? So n can't be 0. Any other restriction, there is none, right? In terms of as long as it's an integer, positive, negative, it does not matter. So just a few things. So what do we know about integers? Well, we know that we use negatives much the same way that we use subtractions, right? So if I were to write out a sentence that is 3 minus 2, or write it out as 3 plus -2, what we should already know is that both of these have the same result. They both give us 1, because a subtraction really is just the addition of a negative, right? So we start thinking about it like that, it becomes easier to understand some of these things. Okay, the same number with different symbols is considered to be opposite. And again, why would that be? Well, it's pretty easy to understand as long as we're thinking about it the right way. If 0 is in the middle of my number line, and we go 1, 2, 3, 4 units to the right of that, that's +4. And then 1, 2, 3, 4 units to the left of that, well, that's -4. Notice that both of these things, +4 and -4, are 4 units from 0. Again, the only thing the negative does is it just changes the direction. So what happens if I were to add these two opposites, add my +4 and my -4? Well, again, I think we all pretty well understand that when I add these opposite numbers, my result is always going to be 0. Pictorially, why is that? Well, +4 tells me I'm going to go from 0 4 units to the right. Right, there's my +4. And then my negative 4 says, well, then from there, I'm going to go 4 units to the left, right? There's my negative 4. And what happens? Well, where do we end up again? We end up back at 0, our result. Okay, so rational numbers are any number that can be written as a fraction. So, for example, 1/2, or 1/3, or 2/5. But notice that these fractions actually also have some similarities when we think about them as their decimals. So if I were to grab my calculator right now and do 1 divided by 2, what I get is I get 0.5. And if I were to do 2 divided by 5, I get 0.4. We call these decimals terminating. So we notice that whenever we're looking at a rational number, if we were to turn it into its decimal, we should always find that those numbers are terminating, except for one example, and that would be something like this 1/3. If I were to plug 1/3 into my calculator, I get 0.333333, and so on and so on and so on. It's 0.3 repeating. That is the only exception to this terminating decimal, is if the decimal is not terminating, it will repeat. So it'll be 3's forever. And you can see that in a lot of different fractions. So for example, if I were to do like 1/7, it's a weird one, but this is 0.142857, and then that whole thing there repeats itself, right? So it's that whole pattern, and then it's over and over and over and over. And what you'll notice is I put this little line over top. That symbol indicates a repetition, that this pattern of 1, 2, 3, 4, 5, 6 numbers happens again and again and again and again. Now, if there are rational numbers, it kind of makes sense that there might be something called irrational numbers. And what an irrational number is, it is the exact opposite of rational number. If rational numbers can be written as a fraction, irrational numbers cannot. If rational numbers either terminate or repeat, irrational numbers won't. So for example, pi. Pi is a well-known irrational number. And if I were to look at pi, it's 3.14159 ... off to infinity. There's an infinite number of numbers in pi, so it never terminates. And the pattern of numbers never repeats itself. It's constantly changing numbers. It's constantly a random value, right? So there is no pattern as well. All right, so that is what a rational number is. So knowing that, is 1/3 a rational number? So pretend like I haven't already said it was, and let's see if we can't explain why. So I'm going to get you to just pause the video, maybe 10 seconds, 20 seconds, and just think to yourself, is it a rational number? Well, yeah, we know it is, but why is it a rational number? Okay, so now that you've had a chance to think about that, let's talk about it. So why is 1/3 a rational number? So let's make sure that we can use appropriate vocabulary and we can define these things. So again, we have to think back to our definition of what rational is. Is it an integer over an integer? And if the answer to that question is yes, it will be a rational number. So yes. And why? Because 1 is an integer and 3 is an integer, right? So integer, can't spell. It meets that checklist, right? An integer in my numerator, an integer in my denominator, we're good. Now, one more thing before we call it a day in this video, but we have to recognize how negatives work. Because these fractions can be considered divisions, what we notice is that if I were to take a calculator and do 1 divided by -4, I get -0.25. And if I were to do -1 divided by 4, I get -0.25. Notice I get the same result. So what that means is that these two are actually the same fraction. So having my negative in the denominator, having my negative in the numerator, they give me the same result. So we simplify that as writing it simply as the negative of 1/4. The negative of 1 divided by 4, which is 0.25, which again is -0.25. Be careful, because a really common mistake students make is they think that when I have a negative fraction, it's a negative in the numerator and a negative in the denominator. But if I were to plug this into my calculator, -1 divided by -4, we get +0.25. So we have to be careful about that. All right, so that is it for the introductory video into rational numbers. So continue watching the videos, and I will see you in the next one.